Welcome to the Link Academy. This video will introduce you to one important topic in VLAN, GVRP. After watching this video, you will learn what GVRP is, why GVRP is needed, GVRP messages types, GVRP packets format, and finally, how GVRP works. In static VLAN configuration, the network administrator needs to manually create the VLANs on each device. When a network is too complex with many VLANs configured on the devices, or the network administrator is not familiar with the network topology, a huge workload is required for manual configurations. In addition, configuration errors may occur due to human error, and VLANs must be reconfigured for every network topology change. To solve static VLAN problems, GVRP was introduced in IEEE 802.1d to automatically create VLANs. So, when GVRP is configured on the network, no manual configuration is needed because devices make use of the GVRP protocol to dynamically maintain the VLANs. Also, when the network topology changes, GVRP creates the dynamic VLAN automatically. GVRP stands for GVRP VLAN Registration Protocol and dynamically configures VLAN. GVRP is defined in IEEE 802.1ad. GVRP is based on Generic Attribute Registration Protocol (GRP), which provides a mechanism for propagating VLAN attributes throughout the entire switching network. When GVRP is enabled, network devices can dynamically deliver, register, and propagate VLAN attributes. GVRP packets are encapsulated in the IEEE 802.3 Ethernet format. In the GVRP, protocol ID field indicates the protocol ID. The value is 1. Message field indicates the messages in the packet. Each message is composed of the attribute type and the attribute list fields. Attribute type indicates the type of an attribute, which is defined by the GVRP application. The value is 0x01 for GVRP, indicating that the attribute value is a VLAN ID. Attribute list indicates the attribute list of a message, which consists of multiple attributes. Attribute indicates an attribute, which consists of the attribute length, the attribute event, the attribute value fields. Attribute length indicates the length of an attribute. The value ranges from 2 to 255 in bytes. The value can be leave all event, join empty event, join in event, leave empty event, leave in event, and empty event. Attribute value indicates the value of an attribute. The value is a VLAN ID for GVRP. This field is invalid in a leave all attribute. End mark indicates the end of a GVRP PDU. The value is 0x00. GVRP participants exchange VLAN information through GVRP messages. Major GVRP messages are: a join message is sent when a GVRP participant wants other devices to register its attributes. Join messages are classified into join empty messages and join in messages. Join empty declares an attribute which is not configured locally. Join in declares a locally registered attribute. A leave message is sent when a GVRP participant expects other devices to deregister its attributes. Leave messages are classified into leave empty messages and leave in messages. Leave empty deregisters an attribute which is not registered locally. Leave in deregisters a locally registered attribute. And leave all messages are used to periodically delete useless attributes on the network. VLAN registration consists of adding a port to a VLAN. When a port receives a VLAN attribute declaration, it registers the VLAN specified in the declaration and the port is added to the VLAN. A port registers a VLAN only when it receives a join in or join empty message. Now let's illustrate how a VLAN attribute is registered on a network. When static VLAN 2 is created on switch 1 and 3, the process is as follows. After the static VLAN 2 is created on switch 1, the switch proceeds to the VLAN attribute declaration to port 1, and port 1 sends a join empty message to the switch 2. After port 2 of switch 2 receives the join empty message, switch 2 creates dynamic VLAN 2 and adds port 2 to VLAN 2. Then, the VLAN attribute is declared to port 3 and a join empty message is sent to switch 3. Switch 3 creates dynamic VLAN 2 and adds port 4 to VLAN 2. After that the registration from switch 1 to switch 3 is complete, port 2 and port 4 are added to VLAN 2, but port 1 and port 3 are not added to VLAN 2 because only ports receiving a join empty or join in message can be added to dynamic VLANs. To allow the end-to-end connectivity in both directions, the port 1 and 3 also need to register. For that, we will need to create a static VLAN 2 in the switch 3. The process is as follows. Static VLAN 2 is created on switch 3. The dynamic VLAN is replaced by the static VLAN. Switch 3 proceeds to the VLAN declaration and sends a join in message to switch 2. Switch 2 adds port 3 to VLAN 2 and the VLAN attributes are declared to port 2 and a join in message is sent to switch 1. After receiving the join in message, switch 1 does not create dynamic VLAN 2 because static VLAN 2 has been created, but will add port 1 to VLAN 2. Now, port 1, port 2, port 3, and port 4 are all added to VLAN 2. VLAN deregistration consists of removing a port from a VLAN. When a port receives a VLAN attribute withdraw declaration, it deregisters the VLAN specified in the declaration and the port is removed from the VLAN. A port deregisters a VLAN only when it receives leave-in or leave-empty messages. Let's say now we would like to deregister, remove, all the switches port from VLAN 2. The process is as follows. First, we will manually delete the static VLAN 2 on switch 1. After removing static VLAN 2 from switch 1, the switch proceeds to the withdraw declaration and port 1 sends a leave empty message to switch 2. When switch 2 receives the leave empty message, port 2 deregisters VLAN 2. Then port 2 is deleted from VLAN 2. But VLAN 2 is not deleted from switch 2 because port 3 is still registered to VLAN 2. At this time, switch 2 proceeds to a withdraw declaration and port 3 sends a leave-in message to switch 3. After switch 3 receives the leave-in message, port 4 is not deleted from VLAN 2 because VLAN 2 is a static VLAN on switch 3. At this stage, VLAN 2 is not yet completely deleted on switch 1 and 2 because they are still learning the VLAN 2 attributes from switch 3. Remember, the switch 3 still has static VLAN 2. To delete VLAN 2 from all the switches, a two-way deregistration is required. The process is as follows. After static VLAN 2 is manually deleted from switch 3, the switch proceeds to the withdraw declaration and port 4 sends a leave empty message to switch 2. After port 3 of switch 2 receives the leave empty message, it deregisters VLAN 2. Then port 3 is deleted from dynamic VLAN 2, and dynamic VLAN 2 will no longer exist on switch 2 since no port is registered to VLAN 2. At this time, switch 2 proceeds to a withdraw declaration and port 2 sends a leave empty message to switch 1. After port 1 of switch 1 receives the leave empty message, port 1 deregisters VLAN 2. Then port 1 is deleted from dynamic VLAN 2, and dynamic VLAN 2 will no longer exist on switch 1 since no port is registered to VLAN 2. Thanks for watching this video, and see you in the next video for GVRP configuration on the switch.